Okay, so now on to question 6, probability question. All right, got to be careful with these. An online shopping site sells boxes of donuts. The box contains 20 donuts. There are 4 types of donuts in the box. So glazed with custard, glazed with no custard, not glazed with custard, and not glazed with no custard. So I'm going to use G and C. G for glazed, C for custard, and then G dashed and C dashed. Now, it is known in the box that half of the donuts are with custard, so that's the probability of getting a custard is a half. 7 out of 10 donuts are not glazed, so that's the probability of G dashed is 7 over 10. And 1/10 of the donuts are glazed with custard. So with probability of glazed with custard. So that is intersection because it's got both. And that's 1/10. All right, now this first one I'm going to rewrite that as 5/10, only because these others are in terms of tenths. All right, so now the question is how do we do it? Now, while the question doesn't ask for a Carnot map or a tree diagram or anything like that, it's probably going to, because it says not glazed with custard. So it's somehow with these two, but how do we all work it out? All right, so the simplest thing to do is quickly to do a Carnot map, two-way table. Different people have. And I need another column and another row. So here's my custard and here's my not custard. Here's my glazed and my not glazed. And so I'm going to fill in, and it says probability of custard. So custard. So it could have glazed or not glazed as long as it has custard. So 5/10 of them have got custard. Some of them are glazed, some of them are not. Probability not glazed, so that's this row here, is 1/10. All right. Then we've got glazed intersection with glazed and custard intersection. That's here. That's 1/10. So now we've got those things. We can go ahead and we can do some find out these other numbers, and when we find out these other numbers, it's going to help us find the answers. All right. So in this column, it's got to all add up to 5/10, and we got one there, so there's 4/10 here. I wrote that wrong, didn't I? It's 7/10, not 1/10. This one here. Those of you hopefully ahead of me, 7/10. Not glazed, 7/10. All right, so that's 3/10. And then we've got these other numbers, what we work out. Now, the thing is, this down this bottom corner, that's got to add up to 1. Because custard donuts and not custard donuts, when you've included them, you've included all your donuts. So it's got to be 1. So that's 5/10 there, which makes this 2/10 up there. And this is 3/10 there, which works out. All right. So now, the donut is chosen at random. Find the probability that it is not glazed with custard. Not glazed with custard, 4/10. So the probability not glazed with custard is 4/10. And of course, we should always give simplest form. Oops, not 2/10, 2/5. All right, there's our 1 mark. All right, so while the question didn't ask us to do that, it was much more straightforward in doing the question when we did draw a Carnot map. All right, next. Now you've got to be careful here with all these words. Each of the donuts in the box are randomly allocated to box A and box B. So each new box contains 10 donuts. One of the new boxes is chosen at random, and then a donut from the box is chosen. Let G be the number of glazed donuts in box A. All right, so we've got to think about what we're doing. And that's this line here. So we choose a box, then a donut. All right, so, and what I'm going to do here is I'm going to do a tree diagram. And again, we're not asked to do the tree diagram. However, by doing it, it's going to make it much easier because we choose a box first, and there's 2 boxes, box A and box B. And it says that we're chosen at random, so because there's 2 of them, half each. Then what we've got is what we're interested in. Find probability in terms of G. G is the number of glazed donuts in box A. All right. Find the probability in terms of this G that the donut comes from box B, given that it is glazed. All right, so let's have a look. We're interested in glazed donuts and not glazed donuts. So in box A, we're told there's G the glazed donuts, that's the number, and of course there's 10, so that's G out of 10. All right. Then we go move to the next one, box B. Now, how many glazed donuts are there? Now, this is where we need to go back. And we need to go back up here. And it says 7/10 of the donuts are not glazed. Now, we had a box of 20 donuts. So 7/10 of 20. All right, so the number of glazed donuts is, so there's 20 in the 7/10 times 20. Sorry, got that right, got that wrong. Not glazed is 7/10, so glazed is 3/10. So 3/10 of the 20 donuts are glazed. So there's 6 glazed donuts in the box, or in the 20. And those 6 have been split between box A and box B. And so if there's G of them, whatever G is in box A, then the rest of the 6 has got to be in box B, and the rest of the 6 would be the total number, 6 minus the G. And again, there's 10 donuts in that box. All right. So I've got a little tree diagram. So let's have a look now. Find the probability that our donut is from box B, given that it's glazed. So let's think about what that means. So this is a conditional probability. So we're looking at the probability of the intersection between B and glazed over the probability of being glazed. And so this intersection between B and glazed, follow along the tree branches and you multiply along those branches. So 1/2 times 6 minus G on 10 over the probability that it's glazed. Now the probability that a donut is glazed is when we come back up to here to our, and here's what we've got. So probability that a donut of those 20, remember we started with those 20, we've just split those 20 into 2 boxes. So the probability that any donut in those 2 boxes is glazed is 3/10. And so that's this probability here. So the probability that it's glazed is 3/10. And then we've now got to sort this out. And the way I would do that is I would have a look and I'd go, okay, so 1/2 times that is 6 minus G on 20. We're dividing by a fraction, turn it upside down and multiply. 2 goes into there and 10 goes into itself once. So we've then got 6 minus G over 6 as our probability in terms of G that a donut comes from box B, given that it is glazed. All right, so it can be a little bit tricky with those. So again, as I said, drawing these diagrams can be very, very handy, even though you're not asked to draw them. It can be very handy. All right, we then go over the page to another bit. C. The online shopping site has over 1 million visitors today, a day. It is known that half of these visitors are less than 25. Let P hat be the random variable representing the proportion of visitors who are less than 25 years old in a random sample of 5 visitors. Find the probability that proportion is greater than or equal to 0.8. Do not use normal approximation. All right, so it says do not use normal approximation. So what we're going to have to do is we're going to have a look and we're going to have to think. We're going to say, okay, well, first of all, the probability of success in the whole population, or the whole, all the visitors, not sample, but all of them, half of them. So that's probability of success is a half. Here we've got a random sample of 5, so n equals 5. And we're talking about less than 25, so they're either less than 25 or they're not. So we're going to be using binomial. It's a funny looking M there, but not to worry. So we're looking at binomial. Okay, so binomial. Proportion. So remember, we're looking at the probability that our proportion is 0.8. All right, so you've got to remember that proportion is, now proportion is the number that we've got over our sample size, n. And in this case, our sample size is 5. So it's the number of we've got over 5. And, excuse me, that's got to be greater than or equal to 0.8. So the probability that X, the number of people, 0.5 times 0.8 is 4. All right, so we've got a proportion, and what we will need to work out for the binomials, we need to work out with numbers, not proportions. And so our proportion is the number we've got over our sample size. So we're looking at the probability, oh, excuse me, is that x is greater than or equal to 4. Now, in this case, probability that x is greater than or equal to 4, now we've only got a sample size of 5, so that's simply probability that x equals 4 plus the probability that x equals 5. All right, so what do we got then? All right, so binomial. So now look up your formula sheet, look at the binomial, and it's going to be 5C4 times the probability of success, which is a half, to the power of 4, times the probability of failure, which is a half, plus 5C5, the probability of success times the probability of failure, and we've got no failures this time. All right, now this 5C5 and the 5C4 and the 5C5, you need to be able to know what they are in some way or other, and there's a few different ways. Pascal's triangle is one way that you can do it. Another way that you can do it is by knowing that if you've got 5 things and you're choosing all 5, there's only actually one way you can do that. And 5C4, so you've got 5 things and you're choosing 4, so one of them gets left out, and there's, because you've got 5, there's 5 ways that you could leave one of them out. All right, because the probability of success and failure here are the same, it ends up that we've then got a half to the power of 5 here, as well as we've got the half to the power of 5 over here. All right, and half to the power of 5 is 1 on 32. So we've got 5 on 32 plus 1 on 32, which is 6 on 32, and we should cancel that down. Still got space in my box. 2 goes into both of those. 3 over 16 for our final answer. Okay, so there's a few things to watch there. What a proportion is in relation to numbers, and also ways that you can work out these 5C4, 5C5, or any others that you would. So you can do it the way that I've done it here, or Pascal's triangle, the 5th row of Pascal's triangle can help as well. I won't go into that now. But that's possible. But the thing is, you need to know, obviously, because you don't have your calculator with you, you need to know ways that you can work out these combinations if you need to.